All right, so let's do one more part here for section 4.1. Still doing review here. And let's begin with another example. All right, let's look at this example that we have here. Suppose that a certain car that was originally worth $50,000, suppose this car loses 20% of its value every year. And we want to figure out then, for this car worth $50,000 in the beginning, initially, if it's losing 20% of its value once every year, then what we want to figure out what's going to be the future, what's going to be the value of this car in 4 years. Okay, so here we got to think about two things. First thing we want to think about is which equation are we going to be using to calculate this amount? Are we trying to calculate a future amount, or are we trying to calculate a present amount? Now, let's see what it tells us. It tells us right at the beginning here that this car is originally worth $50,000, meaning that $50,000 is the initial amount, the initial principal. And we want to figure out what's going to be the value of the car in 4 years, meaning we're trying to calculate here a future amount. So you're going to be using the compound interest formula and calculating the future amount of a certain initial principal after T years. So 50,000, that is our present amount, and we want to use that to find the future value. All right, so once again, let's first denote our values, the numbers that we need. So again, the initial amount is 50,000, so that'll be our value of P. Then our interest rate, which is in this case 20%. But notice that it says that it's losing 20% of its value every year. It's not growing, it's losing its value, which means our interest rate, it's not just 0.20, it's going to be negative 0.20. Negative interest rate, because in this case, we're losing money. Okay, negative 0.20 will be our annual interest rate. All right, and then our value M, well, all it says is that it loses this amount, this much of its percentage, it just loses this much every year. So we can just assume that's once per year. So M will just be 1, and T will be 4 years. Okay, so you want to calculate the present value. Oops, not present value, future value. That's what I meant. We want to calculate the future value, which means to make this calculation, we're going to be using the compound interest formula, which again is noted as A equals P times 1 plus R over M raised to the M times T. All right, so in our case, that's going to be our initial principal, the initial worth, which was 50,000. So 50,000 times 1 plus our interest rate of negative 0.20. So here we have negative 0.20 divided by M, where M is 1, raised to the M times T, raised to the 1 times 4. Okay, so again, let's set this up in our calculators here. So you're going to have 50,000, the initial principal, the initial amount, parentheses, 1 plus negative 0.20. We use parentheses if we want. We can put negative 0.20 in parentheses, negative, and do not forget that this is the minus symbol, this is the negative symbol. Okay, so minus, oops, I've got a lot of numbers here. So 1 plus negative 0.20 divided by 1. Okay, I'll use two right parentheses here. Actually, we don't really need that. I don't think the calculator is smart enough to determine what is negative, so we can just do 50,000, left parentheses, 1 plus negative 0.20 divided by m, which in our case is just 1. Close that with the right parentheses, and then raise this to 1 times 4, m times t, to give us a worth of $20,480 after only 4 years. So this car that's initially worth $50,000, if it's losing its value 20% every year, then after 4 years, it's going to be worth $20,480. So a huge decrease there. Okay. So again, if it's growing, and this, if it's growing, if it's an investment that's going to grow in the future, then our interest rate will be positive. But if it's an investment that's losing money, then in that case, our interest rate will be a negative value. But the setup is pretty much exactly the same, except now R will be negative instead of positive. Okay, so for depreciating values, R will be negative. Okay, now let's do one more example here. Suppose for this example, we're interested in the future value of just $1. So $1 investment. The future value of $1 after only 1 year at 100% annual interest rate. That's going to be compounded and many times a year for these different values of M. For 1, 452, 365, all the way to 10 million. Okay, so let's first identify what type of calculation are we making. Well, it tells us right here, we're finding a future value. So now we're finding the future value. Let's identify our variables. Okay, so our value of P, which in this case, our initial investment is just $1 single dollar. So P is just 1. Our interest rates, well, in this case, the interest rate is 100%, which means R will be 1. Right, so we convert it to a decimal. 100% converted to decimal is just 1. And then M, in this case, we don't know just yet. We have a different setup. We want to test it for different values of M using the table below. And then T here is going to be equal to 1, just 1 year. All right, so let's set up our equation. And our equation, using what we have above here, our equation is going to be that to calculate this future value, we're going to take our initial principal of $1 and multiply this by 1 plus 1 over M raised to the M power. Okay. Or M times 1, or M times 2, so M times 1, which is 1 times 1. Or we'll simplify down, so it simplifies down to parentheses 1 plus 1 over M to the M. This is just 1 plus 1 over M to the M power. So here, our unknown variable is how many times we compound this interest per year. So M is our unknown variable. So let's use this equation of 1 plus 1 over M to the M power to calculate the future value for these differing periods. Okay, so first we have 1 plus 1, or let's write this down. Now, so our first value of M is 1. So you're going to have parentheses 1 plus 1 over 1 raised to the 1 power, which is just 2, right? 1 plus 1 over 1, that gives us 2. 2 raised to the first is 2, right? For our second row, here our value M is going to be 4, so 1 plus 1 over 4 raised to the 4th power. If we plug that into your calculators, we should get roughly around 2.4414. Okay, or if we want, what we can do here is set up a table using our calculator. So let's delete these previous equations and let's set this up in terms of x. So again, our equation is 1 plus 1 divided by, and let's use x to represent m. So x, close parentheses, raised to the x. Okay, where x again, x here is representing m. So let's go to second graph, set up our table here with these numbers, or at least most of those numbers. Okay, so we have 1, then we have 4, 52, 365. We just pretty much known the common values for m, and then we have these here: 8,760, 10,000, 100,000, 1,000,000, and then 10 million. So 8,760. Then we have 10,000. Then we have 100,000. So 1, 2, 3, 4, 5. Then 1,000,000. 1, 2, 3, 4, 5, 6. And then 10 million. So that'll be 7 zeros. 1, 2, 3, 4, 5, 6, 7. Close with a curly brace. 4, 52, 365. Just double checking. 8,760. 10,000, 100,000, 1,000,000, 10 million. And here we get this table here. All right. So let's see. So at 1, as we saw, we got 2. When m is 4, and when the value on the compounding is 4, we get about 2.4414. Then 2.6926 for 52. Then at 365, here we get about 2.714, 2.718 for 8,000. But notice, as m keeps getting bigger and bigger and bigger, as we start increasing the number of times we compound this interest rate per year, our value here, our future value, starts to reach a threshold. It starts to reach a limit, which seems to be around 2.7183-ish, round to 4 decimals. Okay, let me enter our values real quick before we continue. So again, at 52, we had about 2.6926. At 365, we had around 2.7146. At 8,000 here, we had about 2.7181. And at 10,000, pretty much almost the same, 2.7181. Yeah, and then 100,000, you have about roughly 2.7183. And pretty much is the same for 100,000, for 1 million and 10 million. About 2, 3 here. Okay, so about 2.713 as well for 1 million. The same for 10 million. Okay, in other words, we're reaching a ceiling here. We're reaching a threshold. We're reaching a limit for this function of 1 plus 1 over m to the m power. Okay, so thus the limit as m goes to infinity, the number of periods per year, pretty much as this goes to infinity, the limit of this expression of 1 plus 1 over m to the m power reaches a threshold of roughly 2.7183. Okay, for a future investment of $1 at an interest rate of 100%. What's the significance of this value, 2.7183? Well, that is the value of that special number known as E. And that is the value of the special number in math known as E, the constant E. And that's our last item of interest for this review of exponential functions. A constant e. Okay, so e is roughly around 2.71828 and dot dot dot. It's a non-repeating irrational number, which we can round to about 2.7183. Got 4 decimals, that's fine, that's good enough. Okay, so if we're compounding, if the value of m is pretty much heading towards positive infinity, pretty much if we're compounding continuously through each year, if we're compounding our interest rate at every second, every millisecond, every centisecond, or whatever the smaller number will be, and if we're compounding this pretty much nonstop throughout each year, then we're compounding interest rate at a continuous amount, at a continuous compounding. Okay, so let's look at continuous compound statements. Okay, for an initial investment of P, so once again, we're going to be using P here, for P dollars, that are invested or borrowed at an annual interest rate of R. But in this case, this interest rate is being compounded continuously throughout each year for T amount of years, then its future value is calculated using the following equation, using the following compounded equation, which is defined as A equals P times E to the RT. Okay, P times E to the RT, PERT, when compounding continuously. Okay, let's do 2 examples here. Suppose we want to find the value of $2,000 compounded continuously for, say, 8 years at 10% interest. Okay, so there we see that key word, compounded continuously, for initial investment of $2,000 for 8 years at an interest of 10%. So once again, we have done before, let's identify our numbers here. So P, our initial investment, is 2,000. Our interest rate is 0.10. And then T, our number of years, is 8. We do not need to know M for this equation. All we need are PRT. And E is this natural number of 2.7182-ish, or 2.7183 if we're going to use the 4 decimals. Okay, so using these 3 numbers, plug them into our equation, which goes A equals P, which is 2,000, times E, where E is being raised to, all these parentheses to denote this part, where E is being raised to our interest rate of 0.10, multiplied by T, which in our case is 8. Now, you can substitute if you want. You can plug in 2.7183 for E, or we can also make this calculation using directly our calculators here. Okay, so let's go to our calculators. Back to the main menu. And similar to what we have done before, first things first, enter our principal amount, which was 2,000 here. Okay. And then in your calculators, you should see a little button that says e to the x, which is usually fall under the natural log. We're not using natural log just yet. I'll delete that. To use e to the x in this case, in this app, in this calculator for the TI-8384, you need to press second ln. Second ln brings up e. Okay, now you may not get, I'm trying to see if I can delete that just top part. I don't think, oh, no, it doesn't. Now you may not get automatically raised to the exponent here after e. If you don't, use the arrow button to raise it up. okay, if it's not raised up already. But in the exponent of e, we want to put parentheses here, 0.10 times 8 to give us a future investment after 8 years of $4,451.08. Okay, so for this initial investment, 2,000 bucks, if we compound it continuously for 8 years at an interest rate of 10%, after 8 years, this investment is going to grow to $4,451.08. Okay. Let's do one more example, slightly different. Not exactly the same as the previous one, but let's suppose for this next example, we want to find the present value. We want to find the present value of a future payment of, say, $2,611 in 8 years at 12% interest, compounded continuously. Okay, so here we look at present value, or we want to find the present value of a future payment of this amount in 8 years at a 12% interest that's compounded continuously. But notice, this equation is to calculate the future amount. Here we want to find the present amount. So how are we going to go about this? Pretty much almost exactly the same as the present value for compound interest, except instead of P over this exponential, it's going to be P, our future amount. Okay, so we want to calculate the present value for when they compounded continuously. Then what we're going to do is take our future payment, our future investment, divided by P, and divide this by this exponential expression of e to the r times t. Where again, P in this case is representing the future amount, the future value. Okay. And pretty much, if we want to find the present value, we take our future value and just divide it by our exponential expression from the original equation. Okay, so here, our future value, we want this to grow to $2,611. That's going to be our future payment, our future value. Our interest rate is 0.12, and this is going to be the growth of the future payment in 8 years. So T will be 8. And again, we're compounding continuously, which means we're going to be using that value of the natural number of E. Okay, so to set this up, where A, oops, I forgot to mention here. So A in this case is representing our present value. So here to calculate our present value, we're going to take our future payment of $2,611 and then divide this by E raised to 0.12 times 8. 12 times 8. Okay, so using our calculators, let's set this up. All right, so we're going to take 2611 and divide this by second ln for E, where E is being raised to, parentheses, 0.12 times 8 to give us a present value of $999.73. So if this is what the future payment is going to be in 8 years, then that means the present value has to be $9,999.73, almost $1,000. So 999 and 73 cents will be the present amount of this future payment. Okay. Again, pretty much when calculating future values, it's multiplication. And finding present values, that would be division. Okay, and then again, if our investment is losing money, in that case our interest will be negative. And that concludes this first section of chapter 4 here.